Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Zafrullah bin Zaminan. My matric number is DF190055. So, we are from Group 1. Our group member is Muhammad Najam bin Mat Yusof, Muhammad Hazim bin Ahmad Fauzi, Nur Syahidah binti Basunan, and Muhammad Afiq bin Tajul Arif. So, for the introduction, a stadium is a place or venue for outdoor sports, concert or other event and consists of a field or stage either partly or completely surrounded by a structure design. As for modern stadium nowadays, some vast and high quality facilities was prepared to ensure that players and official match can be carried out their duties in comfort and safety. The stadium must be covered to protect spectators from rain and the harsh glare of the sun. Stadium overview. For this project, basketball stadium will be the stadium type for the comprehensive design. The design of the basketball stadium is based on the detailed engineering design, and the stadium consists of a steel truss design for the superstructure and a reinforced concrete design for the substructure part. Based on the typical floor plan of the project, a basketball court and a stage are located under the open stadium, which is intentionally constructed as a multi-purpose building. The stadium can either be a place for basketball game, concerts or other event that consists of a field or stage. As the scope of this project is to provide a comprehensive design of a purpose steel truss of a stadium, the reinforced concrete design for a substructure will not be covered. Furthermore, this stadium overview will be included with a typical floor plan, front elevation, rear elevation, right and left side elevation, roof plan and longitudinal and detailed cross section. Steel truss of the basketball stadium will be analyzed for the determination of truss use and internal forces, design of tension and compression truss member, and last but not least, design of the connection. This is the perspective of the basketball stadium for our project. So as we can see on the top of this slide, this is the cross section of the basketball stadium, and this is the overview for the stadium. Next is the truss concept. The design concept of the basketball stadium is based on trapezoidal roof truss design and double inverted roof truss design. For the choice of trusses that we have choose, the double inverted trusses are used to create a steep angle interior ceiling pitch for the middle portion of the building, and it can offer the interior space additional natural light and a vaulted ceiling in part of the space, which is suitable for basketball court. For the engineering judgment, in case of a very long span pitch roof, trusses having trapezoidal configuration and with depth at the end are used. This configuration reduces the axial force in the court member adjacent to the support. Next is the secondary bending effect in this member are also reduced. The trapezoidal configuration with having the sloping bottom chord can be economical in very long span trusses, that is, the span must be greater than 30 meter. They tend to reduce the web member length, and the chord members tend to have nearly constant forces over the span length. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najhan bin Mat Yusof. My matric card number is DF190019. So I will talk about the design overview. So structural design is the process of creating a structure that is both resource and environment efficient and can safely sustain the applied stresses and load effect. The design characteristic that is concerned with sustainability over the long term, ease of building, and usability is referred to as friendly and is not explicitly taken into account when considering the strength. The term resource consumption describes how labor, time, materials, and other consumables are used in the building construction and maintenance process. So, this section shows some important layout of the basketball stadium in designing steel truss comprehensively. It is important to understand each of the layout carefully. The steel truss design complies with the Euro Code 3, which is design of steel structure. So this is the plan view, which consists of 3 grid lines on the y-axis and 7 grid lines on the x-axis. So this is the side view of the basketball stadium, and this is the cross section where the stages and the retractable basketball goal are located. Next is the detailed roof plan, which is we have 0.4 thick base metal thickness and thick pre-formed GI sheeting and flashing. So next is step pro design, which is we have 3D plan view and side view of the basketball stadium. As for selection of GK, QK and WK, for the dead load, which is GK, we use galvanized C-Perlin carbon steel channel with 0.3 kN per meter square finishes load, as well as roof liner with 0.1 kN per meter square. For variable load QK on the roof, based on Malaysian Standard EN 1991-1-1 2010, table NA7 is used for maintenance and repair purposes, with roof with imposed load of 0.52 kN per meter square, while the wind load on the roof is referred to Malaysian Standard 1553 2002 clause 2.4.2, which is minimum wind load is 0.65 kN per meter square. And last but not least, for load combination, we have 4 load combination, which is number 1, ultimate limit state, maximum 1.35 GK plus 1.5 QK. Ultimate limit state, which is for the minimum, equal to 1.35 GK. Serviceability limit state, 1.0 GK and 1.0 QK. And last but not least, we have ultimate limit state for wind load, which is 1.35 GK plus 1.5 QK plus 0.7 WK. So that's all from me. Thank you.
My name is Muhammad Azim bin Fauzi, and now I will continue with the chapter 3, which is determination of internal forces. So, in determination of internal forces, we use sub-pro analysis to produce the internal force, and in the internal force that from the sub-pro that we got compression and tension, and we also analyze the critical member from our truss, and we got the biggest the biggest values of the truss is 1148 kN, and this is our model in sub-pro analysis, and the red one is indicate our critical member, and then this we have choose 5 critical compression and critical tension member in the table shown, which is the value of the critical compression and critical tension member. And then we make a manual calculation, and we got there are a significant difference between these two analysis. So we believe that the sub-pro analysis produce more accurate result because of in the sub-pro we analyze the entire structure, but in the manual analysis we just analyze just one section. They also have a different in sub-pro reaction, because in sub-pro we apply the fixed support, and at the manual calculation we apply pin and roller support. That's why they have a difference, a big difference value from these two analysis. So I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. We continue the presentation for manual calculation. We start for tension member at beam 1326. So this is the picture of the placement beam 1326 at the start pro. So the NED from start pro analysis is 690.853 kilonewton. First, we will calculate the area. So we got the area 25.12 cm square. Then we propose the equal angle, which is 150, 150, and 15, which is area of cross section is 43 cm square. Then the cross section clarification that we got this section is in class 3. Then for the verification, the design plastic resistance of the cross section MPRD. Then we calculate the MPRD and we got the value is 1182.5 kilonewton. So the design ultimate resistance of the net cross section at hole for fastener, assuming the member are welded, A equal A net. So for NURD, we got 1269.36 kilonewton. So the tensile resistance is limited by the laser of between the MPRD or NURD, but we use the value of MPRD as NTRD because the value is more lower. So the value for NED over MPRD is 0.58 is lower than 1. The next one is the compression member at beam 1232. So this is the picture of the placement beam 1232 at step 4 analysis. So the value of the NED obtained is 799.566 kilonewton. So first we calculate the area and we got 29.08 cm square. Then we propose the equal angle, which is 150, 150, and 15. So the area of cross section is 43 cm square. So the area is 43 cm square. ZG equal to YG equal to 4.57 cm. IY equal to IZ equal to 898 cm power 4. And IV is 370 cm power 4. So we calculate the second movement area for outplane and in plane. So the value of IY is 2003.31 cm power 4 and IZ is 898 cm power 4. So the cross section clarification we calculate, then we got the section is in class 3. Next, the resistance of the cross section and CRT, the value is 1182.5 kilonewton. Then we calculate the buckling resistance of member. So the first one we calculate for in plane. The buckling length NCRZ is equal to 0.9 multiplied with the length of the truss. Then we got the value is 0.8784 meter. Then we continue calculate the elastic critical force NCRZ. The value is 24121.86 kilonewton and the slenderness lambda Z is 0.22. So refer to table 6.2. The buckling curve obtained is curve B and the imperfection factor is 0.34. Then the ratio Z is 0.53 and the XZ is 0.9. Then the calculation for the buckling resistance for MBZRD, we got 1064.25 kilonewton. Then the calculation for buckling resistance for outplane, the buckling length SCRY is 0.976 meter. Then the elastic critical force and CRY, we got 43588.06 kilonewton and the slenderness lambda Y 0.16. So from table 6.2, the buckling curve is curve B. The imperfection factor is 0.34. Then the ratio for Y is 0.51 and the calculation for XY, we got 1. So the bucking resistance for MBYRD is 1182.5 kilonewton. So between the value for MBZRD and MBYRD, we got the bucking resistance in plane is more or less, and the verification is NED over MBRD, and we use the value of MBZRD. So the value we got, the final value is 0.75 is less than 1. Thank you.
Hello, my name is Nur Shahida binti Basunan and my metric number DF190153. So today I would like to talk about design of connection. In this study, we have choose bolted connection in our design. The reason we use bolted connection in our design is because they are easy to use and do not require any additional equipment. Bolt mainly used in connection to resist shear on the surface of plates and tensile force along the axis of the bolt. Bolted connection on the other hand have considerable advantages because they are require drilling and adjusting hole during installation. Cutting the hole may weaken the steel members and increase the use of steel material, as well as increase the workload in the construction due to the members overlapping. So for the recommendation, for safety purpose, the selection of the bolt size is very important and should be emphasized in order to withstand high hand. For recommendation, for safety purpose, the selection of the bolt size is very important and should be emphasized in order to withstand high loads. The bolt size must suitable and reasonable to support the loads. We have used bolt size with diameter 18, grade 4.8, which is suitable for our design. As the result, this design have achieved the designing requirement to ensure the safety of this stadium because the resistance checking for every section is passed. That's all from me. Thank you.